So in this recording, I am going to talk about UMAP. UMAP is one of the techniques by which we can identify or we can visualize our embeddings in a lower dimensional vector space. What it helps us to see, given a question, is there a semantic overlap of the chunks and the question? This kind of like a pre-processing step, right? Before we go to the generation part of the RAG pipeline, this provides a way to identify how much overlap and what type of overlap, semantic overlap I have in my chunks. Or even like if are there chunks which are talking about the same thing, right? Which are, is there a deduplication required, right? Um, So it's a visual way of identifying those overlaps and then later see how we can reduce the overlap by giving more structure to the chunks, right? And the UMAP uh, um, documentation is in this link. It is a fairly flexible nonlinear dimension reduction algorithm. It seeks to learn the manifold architecture of your data and find a low dimensional embedding that preserves the essential topological structure of that manifold. In this notebook, so this is the notebook where it shows how to use it. So let me actually show you a example of how it can help, right? So this is a code I have written where I have used Cohere to do the embeddings, and the embeddings that I did are on this pair of sentences. So Tripura is my home state. So if the question is when was Tripura admitted to India, right? So Tripura, the first time when it got admitted to India, it was admitted as an union territory of India, and then it became a state, right? So this question, if I have the chunks like this, Tripura merged with India in 1949 and was designated as a Part C state, union territory. And then there is another chunk, let's say, which talks about Tripura became a full-fledged state of India in 1972. And then let's say there are some other unrelated chunks. My name is Tripura. I was admitted to Indian Academy of Sports in 1979, just a um, random chunk that I made up. My name is Tripura. I got admitted to Indian National Academy of Fine Arts in 1980. If I have to visualize how this question or the similarity of this question with this chunk, right? If I have to see it in the vector space, embedding vector space, usually the embedding dimensions are very large, right? 1536 or 3072 or 768. But if I can reduce the dimensionality to a 2 dimension or a 3 dimension, it is easier for me to then visualize and then take steps if we see I have any overlap between concepts, right? And that's where UMAP comes into picture, right? So this is what I ran through the UMAP. So I created the, uh, I did the fit transform on those embeds and then visualized using Altair, right? What I did is like I created a chart and saved the chart.html. So let me run again. Let me created it once. So let me delete and run it again and see how it looks like, right? So we get an idea of how UMAP can help, right? So I just ran it and it is running. Once it is done, it should create the, it's taking some time. Yeah, it is done. So chart.html is not done. So if I now open in a Chrome browser, so I did it in a 2-dimensional space, right? Now I can see, so this is, okay, this is one chunk. This is another chunk. This is another chunk, right? This was the question. When was Tripura admitted to India. Now, if you see, it is nearer, this chunk is nearer to this chunk, right? So if I, yeah, this chunk will be nearer, right? So if I look at this chunk, it says Tripura became a full-fledged state of India in 1972, and this one says Tripura merged with India in 1949 and was designated as a Part C state. Ideally, this chunk, my answer should have been from this chunk, right? But now, since the question is near to this chunk, this probably will come at the top, right? When you do a retrieval. Now here I can see if there is a way by which I can add more structure to this chunk, or maybe deduplicate or merge these two chunks together to see if the question gets better answered now, right? Because right now, if it gives answer from this, it will not be, it will be partially right. It will not be completely right, right? And the good thing is the other two, which I said, my name is Tripura, they are far away from the from this vector space, right? From this question, right? But this is a way how we can use UMAP to visualize the vector space and then take some decision on whether to deduplicate or add more structure to the chunks so that the semantic overlap is reduced. So that is what I wanted to show us as part of this recording.